Hello, hello, Professor Kiss here. I want to make a video to show you how to work a practice problem using black shoals and then put call parity. So I'm going to share my screen, and here's my PowerPoint first to show you the black shoals formula. So this is a technique for pricing European style options when the stock can be traded continuously. And for a call option, the price of the call is equal to the stock price times a normal distribution of D1 minus the present value of the strike times the normal distribution of D2. And you can see that that's a probability of an outcome from a standard normal distribution will be below a certain value, like D1 and D2. And these are the formulas for D1 and D2. You can pause the screen to look at the formulas. Sigma is the annual volatility, the standard deviation, and T is the number of years left till the option expires. So this is just what your normal distribution looks like. The area under the normal distribution curve here is D. Now, there are only 5 inputs needed for black shoals: the stock price, the strike, the exercise date, the risk-free rate, and the volatility of the stock. Everything except for the volatility is easily observed. Now, let's look at a practice problem. CLW does not pay dividends. The standard deviation is 45%. The risk-free rate is 5%. It has a stock price at 24. We're going to value an option with a strike of $30. So the present value of the strike is 30 divided by 1 plus the risk-free rate raised to the half power. And then D1 and D2 are calculated as shown. But what I'd like to do is do the calculations in Excel. So I'm going to do a new share to get the Excel up. So you can see here, there's the stock price at 24, the strike of 30, and all the variables. And now, how do I get the present value of K? I take the strike 30 and I divide it by 1 plus the risk-free rate raised to the T power, or the half here. And then to get the stock price divided by the present value of K, I just divide these two. And then ln, the natural log function, I'll just show you that that's a function. So I go to functions and I click natural log, ln, and it gives me some possibilities. I click go, and there's the natural log function. I click OK. And I want to get the natural log of this term that is in this row. And there is my natural log. And the next thing I do is to take T and get the square root of that. And that is another function, the square root function. And there's my standard deviation. And I take my standard deviation multiplied by the square root of time. And then I need to get these two terms here, which you can see, the natural log of the stock price divided by the present value of K, and divide that by the standard deviation times the square root of time, and that's minus 0.6246. And then I want to get the standard deviations times the square root of time over 2, and that's 0.1591. Next, I need to get my D1 and D2, And D1 is just adding these two terms together. And D2 is taking D1 minus the standard deviation times the square root of time. And they're both negative right now. This is price, the stock price is lower than the strike. It's out of the money. Now I use my normal distribution, and you can see the function that I'm using is called norm.s.dist. And let me show you this function. So I will go to functions, and I've used it recently, so it should be in my recent functions. No, I haven't used it here. So I'll go norm.s.dist and click go. And there is the function that I want. Click OK. And now I want it to give me the normal distribution of D1. So there is D1, and then it wants me to say either true or false. And of course, I'm saying true here. And then I click OK, and you can see that N of D1 is 0.3208, and N of D2 is done similarly as 0.2166. Next, I multiply the stock price times N of D1, getting 7.7 approximately. And then I multiply the present value of the strike times N of D2, and that is 6.34 approximately. And now I work it through, and I get that my call price is $1.36. Now I have a similar formula for the put, but the fastest way to find the value of the put is to use a function called a formula called put call parity. So let me go back to my PowerPoint and show you put call parity. And I thought I'm going to bring up my PowerPoint here. There we go. So here is the formula for put call parity. The put is the present value of the strike times 1 minus N of D1 minus the stock times 1 minus N of D2. And now let's look at my answers, and it's approximately $6.63. And then let me share that with you in the Excel. So now here for put call parity, you can see with the formula, I need 1 minus N of D1 and 1 minus N of D2. And then I take the present value of the strike, I multiply that by 1 minus N of D2, and I take the stock price and multiply that by 1 minus N of D1. And there I get my value for my put, $6.63. Let me go back to, I'll stop sharing. So what I have shown you is how to do a couple of practice problems, which should be useful for you when you're working the assignments in this course. How to use Black-Scholes to price a call, how to use put call parity to price the put. Thank you very much. See you in class. Bye.